Section 12.4 of our textbook deals with expected value. Alright, now what does expected value do? It basically is used to predict the results of an experiment, and here's really the key to this: after many trials. Right? It's really not going to be valid just for, one trial of something. It's really going to be more valid after many trials. Okay? So it gives us an idea of what we can expect in the long run. So after many trials, that's in the long run. And it can also be used to determine whether or not to take a chance on a particular business venture, and you'll encounter some of those problems in the homework. All right. So the first thing I do is I just give you the formula for the expected value, which is this. Right? E, which is the expected value, equals P1 times A1 plus P2 times A2 plus, and so on, up to Pn times An. Now, that looks complicated, but it's really actually quite simple. It's just basically multiplying probabilities of each event by the amounts, usually money, that are going to be gained or lost when those events occur. All right? And an important thing to note is that the P's must add up to 1. Right? When you take all the P's and add them together, right, P1 through Pn, they have to add up to 1. So in other words, that just means that the events that you're dealing with have to cover the entire sample space, right? Because the entire sample space would add up to 1, right? The probability of the entire sample space would add up to 1, okay? So I start off with a simple example of Sam rolling a fair 6-sided die, all right? So each time he rolls a 3 or a 5, he wins $5, and each time he rolls a 1, 2, 4, or 6, he loses $2. So the question is, should he play this game? Right? Should you play this dangerous game? Right? Because sometimes you're winning $5, sometimes you're losing $2. So really, there's only 2 events that are going to go on here. Right? Right? He's either going to win the money or he's going to lose the money. So the first event occurs when he wins the money, and the second event occurs when he loses money. Okay, so what's the probability that he wins money? Now, he wins if he rolls a 3 or a 5. So there's 2 outcomes in which he would win. So in other words, his probability of winning is going to be 2 out of 6, right, or 1/3. And he loses when he rolls a 1, 2, 4, or 6. So there's 4 outcomes in which he can lose, so the probability of him losing is going to be 4 out of 6. Okay? And then you can see I gave you the calculation, right? The expected value for this game would be E, which is going to be 1/3, which is the 2/6, right? The 2/6 I really reduced to 1/3, times 5, which is the amount of money he wins if he wins. And then I add that to 2/3, which is really 4/6, right? I reduced it to 2/3 here, times -2, right? And notice that it's negative because if he rolls those 4 numbers, he's going to lose $2. So that's a -2. And then I just do that calculation. 1/3 times 5 is 5/3. 2/3 times -2 is -4/3. So I end up with 5/3 minus 4/3, which is 1/3. Okay? So the expected value is 1/3. Okay? And what does that mean? The fact that it's positive, that tells us that in the long run, we can expect him to actually win money in the long run. So in other words, this isn't really that dangerous of a game. Chances are he's going to win money in the long run. If he keeps playing it over and over again, he's probably going to win money. All right. So, for example, if he rolled the dice 300 times, actually it's not dice, it's just die, right? It's a singular. So if he rolled the die 300 times, what would he be expected to win, right? So you got to remember, this 1/3, this is for just one trial. So if he rolls 300 times, you would expect him to actually win 300 times 1/3, And 300 times 1/3 is actually 100. Okay? So if he rolled the die 300 times, he would be expected to win $100. So how did I get that again? I just multiplied the expected value of 1/3 by the number of trials, which was 300. Okay? So that's a simple example of expected value, just with a simple game of rolling a die. All right. Now, if the rules were changed a bit, and he would win only $3 for rolling the 3 or 5, but still lose the 2 for rolling a 1, 2, 4, or 6, now how would the calculation change a bit? What would happen is the A1 value, right, which is the amount that he wins if he wins, changes to 3. Right before it was 5, now it's 3. So the A1 value is 3. The A2 value, he still loses $2. So that would be -2. So my expected value is just going to be A1 P1 plus A2 P2. Again, it's the same calculation, the same formula, but in this case the A1 is only 3. So that's the only number that's going to change. That's going to stay 3, and the P1 is still 2/6 or 1/3, and the A2 is -2 still, and the P2 is still 4/6 or 2/3. And again, the thing that you should note here is that the probabilities add up to 1, right? That's something that you should check on, really, when you do these problems. Make sure that the probabilities add up to 1, and 1/3 plus 2/3 is 1, okay? So 3 times 1/3 is just 1, and -2 times 2/3 is still -4/3. So 1 minus 4/3 is actually a -1/3. So if he's only winning $3 when he rolls those numbers, his expected value actually comes out to be -1/3. Okay, so in this case, he should expect to lose. And again, this is in the long run. I mean, could he play twice and win both times and walk away with, in this case, $6? Sure, he could, but in the long run, he's probably going to lose. Because when he wins now, he's only winning $3 versus when he loses, he's still losing the 2. So in this case, I would advise him not to play, because in the long run, he's probably going to lose. All right. Now, a lot of times with these expected value problems, like the one that we just did, there was no fee involved, right? He was just playing, and all right, he rolls the die. He's either being given $5 or having to pay $2, right, or losing $2. But a lot of times these problems involve like raffles or something like that, where you actually have to pay to play. So in this case, we have a problem from the textbook, page 75726, which says that 500 raffle tickets are sold for $2 each, and there's one prize of $400 that's going to be awarded. And Raul Mondesi, not the baseball player, I don't think, just Raul Mondesi, purchases one ticket and determine his expected value. Okay? And I say at the very beginning, there's really only one trick to this problem, and it pretty much comes up in all problems like this where you have to pay to play something. Since you're paying to play, right, when you win the $400, you're not really winning $400 then, because you initially paid $2. So if you win $400 but you've paid $2 to play, you're really only winning 400 minus the 2, which is 398. So in this case, the 398, that's going to be your A1 value, because that's the amount he's winning if he does win this raffle. Okay, so A1 is 398, and if he doesn't win, he's just going to lose his $2. So what that tells you is that A2 is really negative 2. So A1 is 398 and A2 is negative 2, and there's only one winning ticket out of 500. So what that tells us here is that the probability that he wins, right, P1, what we'll call, is just 1 out of 500, because he's only buying one ticket. Right? If he's buying 2 tickets, then his probability of winning would be 2 out of 500. But he's only buying 1, so his probability of winning is 1 out of 500, and therefore the probability that he loses is great. Right? The probability that he loses is actually going to be 499 out of 500. Right? Because again, the P's have to add up to 1, and in this case, again, they do. Right? So what I do, I just use my formula. I have everything down written that I need. P1 times A1 plus P2 times A2. So P1 would be 1 out of 500. So his expected value is going to be 1 out of 500 times the amount that he wins if he wins, which, like we said, is only 398, plus P2 times A2, which in this case is 499 out of 500, times the amount that he loses if he doesn't win, which is just negative 2. Right? So what would this calculation end up being? It would end up being 398 over 500 minus 998 out of 500, which is actually negative 500. I'm sorry, no, negative 600 out of 500, which is really negative 6/5, right? Because 398 minus 998 is negative 600, and negative 600 over 500 reduces to just negative 6/5. So in this case, his expected value is negative 6/5, which you would figure would be negative, because, I mean, is he going to win? Most likely not. He only has a 1 in 500 chance of winning there. Okay? So that's just another simple example of expected value. All right, and then the only other thing that's really touched on in this section is this whole idea of fair price. Now, what is fair price? It's really the cost that would result in an expected value of 0. So in other words, the house, who's ever like in charge of these games, right, these raffles or whatever, wouldn't be winning or losing, right? They'd be breaking even. So, in other words, all the money that they take in for a raffle, they're then paying back out in the form of a prize. Okay. Now, yeah, it's a nice concept, but it's not practical because, of course, the house, like casinos and things like this, are in it to make money. So they're not going to charge a fair price because then they're not making any money that way. Okay. But the formula anyway for fair price would be expected value plus cost to play. So like in this case, in the case of this raffle ticket problem, the fair price, which we'll call FP, is going to equal the expected value, which was negative 6/5, plus the cost to play. And what was the cost to play? It was $2 for a ticket, right? So it was negative 6/5 plus 2, which is really 4/5. So the fair price is 4/5, which you should probably think in this case as a decimal, because you're dealing with money. So this is really 80 cents. And again, I write at the bottom there, it should make sense because in this case the house will be paying out all the money it collected, right? It wouldn't make any money because if it collected 80 cents per ticket, right? 80 cents per ticket times, how many tickets were there? There were 500 tickets, right? Is that true? 500 tickets? I don't remember anymore. Yeah, 500 tickets. So if you charged 80 cents per ticket and there were 500 tickets, this means they would be taking in $400, but then they're also paying out $400, right? So everything they take in the form of revenue for their raffle tickets, they'd be paying out in the form of a prize. So the fair price is 80 cents in this case.